All right, nerds. Let's continue working in chapter 9, talking about rational functions, rational expressions. On Friday, we did multiplying and dividing rational expressions, which, as it turns out, that's the easy part, multiplying and dividing. Hardest part about that was, did you know how to factor, right? Like, all you had to do is factor everything, and if you had a factor that matched on the top and the bottom, you got to cancel it out, and then you said, you know, x can't equal whatever the 0 was of the factor that you canceled off the denominator, because you can't divide by 0. I should do one of those, like, how do they do it? Like, video link is in the corner or whatever, you know how they do? Like, if you didn't see my previous video and they point at their corners, I don't know how to do any of that. But anyway, I should do that. Wow, that would be some really good production quality. Anyway, today we're going to move on to adding and subtracting rational expressions. And if you recall, in mathematics, rational means fractions. Who knows what is necessary for you to have in order to add or subtract fractions? A common denominator, yes. Melissa hit the nail on the head. You need a common denominator. I was waiting for you. Your conversation was important, I thought, so I was waiting. Jamming out. Oh, okay. Anyway, common denominators are necessary for you to add or subtract fractions, and just because x's get introduced does not mean that those rules change. You learned how to add fractions at some point in time in elementary school, and the way that you find common denominators in elementary school, I don't even know what I was saying before I paused it. Anyway, all right. So in elementary school, when you learned how to add or subtract fractions, you learned how to find least common denominators. Least common denominators, least being the key word here. And the way that that worked in elementary school was you had to know your times tables, didn't you? If I asked you to do something like, you know, 1 over 8 plus 1 over, I don't know, 24, you'd need to find the least common denominator. Between 8 and 24, what is the least common denominator? It's 24, isn't it? But what if it was something like this? 1 over 8 and 1 over 12? No, it's still 24. Let's get another number. How about... Ooh, I want to think of a good one. How about 6? See, it's not 24 now. Or is it still 24? Still 24. But how would you have known that without knowing all of your multiplication tables would be the question. See, what a lot of you do when you're trying to find the least common denominators, rather than know the times tables, is you have just found a way to cheese the question. You go, I'll just do 8 and 6. I'll just multiply those two things and I'll get 48. And is 48 a common denominator? Yes, of course it is. 48 works. And could you still get the right answer? Yes, of course you could. But it's going to require you to do a lot of reducing at the end. So you're like, well, whatever, Mr. M, I would rather just reduce than try to find the least common denominator. And what I'm telling you is, you want to be able to find the least common denominator because simply just multiplying them is going to start becoming very, very tedious. You don't want to go through that process of just simply multiplying your denominators. So what would you do then? I would say something that you should have been taught how to do in elementary school. In elementary school, when they tell you find the least common denominator, I'm pretty sure that they go, what's the smallest number that 8 could go into and 6 could go into? And then you're left with a room full of students all trying to think of their times tables and figure out a number that both of these values go into, right? Is that how it works? It is, right? Well, I think that it should have been approached differently. I think that we should have been told, factor your numbers. So if we fully factor the number 8, what can we break it down into? 2, 2, and 2. So you could break this down into 1 over 2 times 2 times 2, and the number 6 factors into a 2 times a 3. Now, the way I said it in first period is, in order to find the least common denominator, think of your denominators as being jealous people. I want what you have because I don't like that you have something I don't. They're jealous. This denominator is jealous of this denominator because this one has something it doesn't. What is this jealous of? The 3. So the least common denominator would require me simply to multiply by 3 on the top and bottom. By the way, this is 24, the least common denominator. You could have also said this. What is this one jealous of? It's got the 3, and it's got a 2. You know what it doesn't have? 2 more 2's, which would have been 4. By the way, that is 24. So I feel like that is the best way to find a least common denominator. And I feel like if you had been taught to find least common denominators that way, it always would have been easy. Basically, factor whatever you're looking at, and then get jealous. Ask, what is this denominator jealous of that the other one has? And it's always multiples. What multiplier does that guy over there have that I don't have because I want it? Also, you might have noticed that what I did in order to get a common denominator was I multiplied to the top and bottom. Are you ever allowed to add or subtract to the top and bottom? No, because that changes the value of the fraction. Can you raise it to powers? Can you do radicals to the top and bottom? No, because that changes the value. The only thing you're allowed to do to the top and bottom of a fraction is multiply by something. Because 3 over 3 is 1, I haven't actually changed it. 4 over 4 is 1, I haven't actually changed it. Okay? So you now know your job is factor and then look for missing factors. I'm aware that you probably don't have to do that for these. Hey, 8 and 6, it's almost like I knew that was coming. I'm aware that you don't have to do that for these. But I want you to practice the skill set. 2 and x does not factor. But 4 can be thought of as being 2 and 2. So let's pretend it said 2 times 2. What is this denominator jealous of then? A second 2. It doesn't have a second 2. So what we're going to do is I am going to write a 4, but we see that it's a 2 times 2. We're going to multiply the top and bottom by another 2. And then obviously, what is this denominator jealous of? What's it missing? Clearly it's missing an x. So we put an x there, and we put an x there. Great. Okay. Purple. Feeling purple. Here, distribute. You have 2x minus 4 over 4x. And x times x is x squared over 4x. They have a common denominator. You can add these two fractions now. If we had like terms, we would combine our like terms. And it gets us x squared plus 2x minus 4 all over 4x. Now, if anything could factor, we would factor and look to cancel like we did on Friday. We're always trying to simplify as much as possible. But there are no two numbers that multiply to -4 that add to 2. So there's nothing else we can do here. It is finished. Would anybody care to ask me any questions about it? Why couldn't you? Why didn't you? Could we? Things like that. Because typically there's a couple questions. And questions are good for the video. No questions. All right, well, how about this? Can I cancel these 4s? Allie says no. Why not, Allie? Well, the fact that one's negative and one's not doesn't really matter. And I mean, if it just said 4 over 4x, I could cancel the 4s, right? Yes. Of course I could. But why can't I here? Jared? Well, it's not even because it's x squared. I mean, if it had said 4x squared over 4x, I could cancel. So more simple, what's stopping me from reducing anymore? What's stopping me from crossing off x's? What's stopping me from crossing off 4's? It would change the value, but why would it change the value in the way it's sitting than if it had just said that? I can get away with it here, but I can't get away with it here. What's the difference? Well, yeah, that's what Gavin was saying. It would change it. It would make the value completely different. Let me make it more obvious. Why am I allowed to cancel the 4's here, but not allowed to cancel the 4's here? What's the difference? If there was a 4 in front of this x, I still would not be able to cancel these two 4's. Come on, guys. Wow. It's the plus sign. You can't cancel things that are held together with addition and subtraction. I specifically said you can only cancel factors. Remember Friday? The last lesson, we canceled things that were held together with multiplication dots. No, nobody remembers anything. Okay. All right. Well, okay. Some people still have their own side conversations. Okay. Well, anyway, all right. I'll just move forward. Hopefully nobody misses that on the test. Okay. Yeah, so we just saw 8 and 6. We already know that this 8 wants the 3 that this 6 has, but this 8 is also going to want the x that the 6x has. Alrighty, so what's going on? We know that 8 and 6, the least common multiple of 8 and 6, which will be our least common denominator of our two fractions, is 24. So I know that I had to multiply by a 3 on the top and bottom. This denominator is also missing an x, so it's not multiplying by 3, it's multiplying by 3x. That makes the least common denominator 24x. That means this is missing a 4. Because 8 times 3 is 24. And so 6 times something, I need to get that 24. So it's the 4. On top, I have a 9x squared and over 24x. And then I get a minus. Here I'm going to distribute. It's going to give me 4x minus 16 over 24x. And because I have like denominators, I have the common denominator, I can literally just put these two fractions together and then combine like terms. Oh, there are no like terms. So we would get here 9x squared minus 4x minus 16 all over 24x, right? Everybody cool with that? Okay, so you want to know where the 3 came from? No, the x. Because this one has an x and this one doesn't. That's why. No other questions about that one? Ah, finally. Someone has a question about it. Yeah, what's up? Uh-huh. Yeah. There it is. Someone sees it. This minus sign has to be distributed. So this minus 16 is wrong. And would 9x squared minus 4x minus 16 be waiting for you on my test? You better believe it. It'll be worth partial credit. But yeah, I will definitely have that on my test because I'm looking for the students that have their basic algebra skills. And that basic algebra skill is distribution. Because a minus sign is actually a multiplier of -1. And if you're concerned that you're going to goof that up, if you're concerned that you're going to mess that up, you can always change the minus sign to a plus sign and then just multiply this by -1 at the very, very beginning, if you would like to do that. It's completely up to you, though. But watch out. I'm going to put minuses between my fractions, and I'm going to be looking for people that know to distribute that minus sign. Good catch. All right. Next. Okay, so we're looking at these two things. Question of the hour. What is this denominator jealous of? What is this one missing that this one has? I'm sorry? So what would you do to try to make them the same? Multiply this by -1. So that would be -x plus 4. Not quite. Well, can you add to the top and bottom of a fraction? Cannot. Okay, Daniel. Multiply by -1/4. That would give me -1/4 x plus 1. So still doesn't match. Neither one of these factors, right? What's their GCF between an x minus 4 and an x plus 1? You guys are killing me right now. Do I have to spoon feed it to you? I'll just tell you, it's not worth it. They have absolutely nothing in common. This is jealous of x plus 1. This is jealous of x minus 4. They have no common factors. Since they have no common factors, you're forced to multiply them to each other. I don't know. Period 1 jumped on that instantly. I'm not sure what's going on right now. So this one needs the x plus 1 that the other one has. And this one needs the x minus 4 that the other one has. I mean, I went through this whole process of telling you factor and then look for the multipliers, right? This is fully factored. This is fully factored. So what would I have to multiply this by so that it has everything that this has? I'd have to multiply by x plus 1. See, 8 and 6, they have a GCF. And that's why I need to be able to break them apart and ask what's missing. But x minus 4 and x plus 1 have absolutely nothing in common as far as factors are concerned. So you have to do that. Also, that's a minus sign. If you're concerned that you're going to mess it up, feel free to do this. It's the same result. Now I'm going to distribute my 2. I'm going to get 2x plus 2, because that says plus 1. It looks like an h, but it's not. Gives me 2x plus 2 over, leave your denominators factored, because you are hoping that when you combine your like terms, maybe you could factor again and something will cancel. That would be the ultimate goal. Because, you know, you're trying to make these things as simplistic as possible. You want less things in fractions. It's always better than more things in fractions. Combine your like terms. Negative x squared, 2x and 4x makes 6x plus 2. It doesn't matter which of the two factors you write first on the denominator. Order of multiplication doesn't matter. You could say that there's a negative GCF and factor a -1 out, and then say put that negative sign in front of the fraction if you wanted to. It doesn't really change much, but let's go ahead and do it, because I did tell you that anytime a polynomial begins with a negative number, you could say there's a negative GCF. then you'd just be looking to see if you could factor and cancel. Are there two numbers that multiply to -2 that add to -6? No, there's not. So this is finished. And either one of these I'd say is correct. Just know how to move between the two, because I don't know how I would approach that on my test. Or I might just avoid it on the test. Who knows? I don't think factoring out a -1 is too much to ask. So the reason why we're not going to distribute on the bottom is because well, one, you hope you could factor and cancel. And two, when we get to graphing, you want to be able to see what numbers x can't equal for the graphs. That's why we don't distribute the bottoms. Is it wrong to distribute the bottoms? No, but that's not what it would look like on my test. We typically leave everything in its factored forms because it makes graphing easier. Why can't you cancel out what? Here? This. Because if I cancel, it's going to get me right back to that. That would be like canceling out these two red things, right? But then that just gives you what you started with. You don't want to do that. The idea is make them one fraction. And then after you've made them one fraction, look for things that could cancel after you've factored. This one doesn't have anything. But you will see it happen in the notes where after we've combined our like terms and we've factored, we can actually cancel things. Sometimes it happens, sometimes it doesn't. Okay? What's the denominator of this 2x? 1. So I hope it's obvious that this denominator wishes it had an x plus 2. And this denominator doesn't need anything. It is the least common denominator. Sound like someone in the back said, ask him. Like they're arguing over who should ask me a question. Did I hear that or no? No? Okay. Anyway, going to distribute my 2x there. What color is next? I'll go back to purple. Distribute my 2x and I will get 2x squared plus 4x over x plus 2. And I'm adding an x minus 2 to that. Combining like terms, I've got a 2x squared, a 4x plus x, and a minus 2. And then, again, after you've combined like terms, check to see if you can factor. 2 times -2 is -4. Are there two numbers that multiply to -4 that add to positive 5? No, there's not. So nothing factors. Now, if it had said 2x squared plus 5x plus 2, then it would have factored. No guarantees that something would have canceled, but the way it sits, it doesn't factor. So this is finished. If you'd care to ask me a question, I'm all ears. All right. Back to blue. Finally, something that requires us to factor at the beginning. This denominator is a quadratic. We need to factor it because we need to see what factors it has and what factors it's missing compared to the other one. Two numbers that multiply to -24 and add to 5 are -3 and 8. So you got the x minus 3 and the x plus 8. Got a 12 up here. Plus and 3 over x minus 3. Is this denominator missing anything that this denominator has? Nope. But this denominator is missing something. What's it missing? It's missing that x plus 8. It's jealous of the x plus 8, so we throw the x plus 8 as a multiplier on the top and the bottom. Leave everything factored because you're hoping ultimately that something will simplify, and that's much easier to deal with if everything is factored. Then over here we have a 3x plus 24, an x minus 3, and an x plus 8. Oh, there we go. When you combine like terms, you've got 3x, 12 plus 24 is 36. So you get 3x plus 36 all over x minus 3, x plus 8. And remember, the order of these two factors doesn't matter because the order of multiplication doesn't matter. And this numerator happens to factor. So we're going to factor it just in case we have something that cancels. There's a GCF of 3. And nothing factors. Nothing cancels. But we still leave it like that because, once again, things are easier to graph when they're factored, and we will be graphing eventually. You want to be able to see the zeros of the numerator and the denominator. They're both important structures in our graphs. So what do you think about factoring first and then figuring out what pieces are missing? Can we handle that? Awesome. Then I'll flip the page. And we'll get to the fun questions. Factor everything that can be factored. First of all, there's a small mistake on this question. Very easy to fix. This minus sign was supposed to be a plus sign. Make it a plus, not a minus. Please. Sorry about that. Let's get to factoring. The two numbers that multiply to positive 12 that add to negative 8 are negative 2 and negative 6. I have a minus sign right here in between these two fractions. I'm going to leave it that way. If you're concerned, you could distribute it right now and say that it's negative 2 minus x or negative x minus 2 and make it a plus sign. But I'm not concerned. I'm going to leave it as a minus for now. I'm going to write x plus 2 because 2 plus x is, that's frustrating. And down here, I do have a factor, GCF, that will come out of both of them. 2x. Okay. And now we can identify things that our denominators are jealous of. What is this denominator wishing it had that the other one has? 2x. And what's this one missing? X minus 6. And there it is. What color did I just do? All right, I'm on to green now. I am going to distribute here, and I am going to distribute here, and afterwards I am going to distribute here and combine my like terms. I'm not going to distribute on the bottom though. 2x squared plus 2x. I'll leave the minus sign for now. I'm hoping by now everybody in the room knows how to FOIL, do the distribution process here. 2 and negative 6 adds to negative 4. 2 times negative 6 is negative 12. So x squared minus 4x minus 12. Boom, just like that. And we will be very, very careful to remember that we're actually subtracting an x squared. we're subtracting a negative 4x, and we're subtracting a negative 12. And anytime you have to say subtracting a negative, that's actually adding. So I have 2x squared minus an x squared. 2x minus a negative 4x, that's 2x plus 4x. And nothing minus a negative 12, that means plus 12. And then you would hope that maybe something factors that you can cancel out. Are there two numbers that multiply to 12 that add to 6? No, there's not. Shucks. There's two numbers that multiply to 12 that add to 7, but that doesn't help me at all, does it? Nope, that's it. It's done. Finito. So yet, so far we haven't seen something factor out yet. You know, cancel out the top and bottom. You're about to. Questions before we get to something that does that? Or, you know, this question is about to have 3 denominators. Anything I can help you with so far? It worries me because, you know, typically students have questions. All right. This question feels purple. Factor everything. Actually, I'll start in black. So this denominator has a GCF of x. X squared minus 4, that's the difference of 2 squares. That's a special case. It factors x plus 2x minus 2. Because this is just a number, I think that it would be beneficial to say, instead of minus this fraction, say plus and put the minus sign on top. Because if you do that, you're much less likely to forget to distribute your negative sign. Time to talk about jealousy. What does this denominator want that somebody else has? X plus 2. What's this one missing? Yeah, it's missing this entire denominator, the x plus 2x minus 2. At least we have an easy numerator to multiply that to. And lastly, what's this one's denominator want? It wants an x. I haven't written in orange yet today, so break out ye olde orange pen. Across the top, distribute the 2. You get 2x plus 4. And then plus. We know what x plus 2 times x minus 2 multiplies to give us this because it's, well, we just factored it. That's where that came from. But also because whenever you multiply conjugates, you square the front, square the back, put a minus sign in between. You know, a squared minus b squared. So x squared minus 4. And lastly, oh, nothing to distribute. It's just negative 3x. Sorry. Cool. We can combine our like terms. Make sure that polynomial is in standard form on top. I've got an x squared. I have a 2x and a negative 3x. That's minus x. And I have a 4 plus negative 4. Oh, 4 and negative 4 cancel. How about that? Our numerator factors. It has a GCF of x. And if you see a factor that is in both the numerator and the denominator, you can cancel it out like we did on Friday. And what in the world? Look at this. I can cancel an x off the top and the bottom. But because I crossed an x off the bottom, I have a removable discontinuity. I have a deleted point. I have a hole in my graph. My fraction simplifies to this. And it looks like there's only two numbers that x can't be, but you know darn well there's a third number that x can't be. And this doesn't show it to me. What is that number that x also cannot equal? 0. Right there I crossed off an x outside of the parentheses. Its solution would have been 0. X cannot be that 0 then. And that's from Friday's lesson. If you weren't here Friday, make sure that you watch that video. Get those notes filled out, and then ask me questions. And we saved the best for last. A compound fraction. That means fractions inside of fractions. Yo, dog, we heard you like fractions, so we put fractions in your fractions. But you guys might be too young for the yo, dog memes, huh? Yo, dog from Pimp My Ride, MTV. I'll show you after the video. Anyway, just because the math looks different does not mean the rules have changed. In order to add those two fractions or subtract those two fractions, you're going to need a common denominator. We'll find it and we'll make it happen. In order to subtract those two fractions, we're going to need a common denominator. We'll find it and we'll make it happen. So we're going to treat this as two separate questions. Nothing is even going to have to factor. What is this denominator jealous of? X. So I'm going to toss an x here and an x here. What is this denominator jealous of? 2. I'm going to throw a 2 here and a 2 here. Awesome. Now we got our denominator. What is this denominator in need of so that it matches this one? Another x. What does this denominator need? Nothing. It is the GCF. Let's get back to blue. All right, on the top, I have x squared over 2x minus 4 over 2x, which is going to give me x squared minus 4 over 2x. But then I have more fraction work going on down here. I've got an x minus 2 over x squared. Now think back to Friday. When you have to divide by a fraction, what are you actually going to do? Keep, change, flip. Multiply by the reciprocal. Keep the first fraction what it is, change the division to a multiplication, and flip that second fraction over. And guess what? X squared minus 4 factors. This is a Friday question now. From Friday's lesson, anytime you have a fraction with a matching factor on the top and the bottom, they cancel each other out. And we know darn well that I could multiply this and have it as one fraction, which means whatever's on top of this is on top of everything. Whatever's on top of this is on top of everything. So these two x minus 2's cancel each other out. Peace. Now there's a hole in the graph. there's an x value, I have to mention that x is not allowed to equal. Oh, you know what? We break out the special occasion yellow pen. That's what's up. Because this one has an x in the bottom, which means I can cancel one of these two x's. Instead of writing it as x squared, I could have written it as x times x, right? Which means this one x cancels one of these two x's, giving us a final simplified result of an x and an x plus 2 on the top. And on the bottom of this fraction is just a 2. But there were two numbers that x was not allowed to equal. I can't see that anymore because they've been crossed out. What are those two numbers? 0 and 2. Good. Would anybody care to ask me any questions about that? I don't know, man. Y'all were quiet today. I was fully expecting some questions. Yeah, it's okay. Thanks, nerds.